So, to recap the lesson, because for one, not everyone has me as a teacher, and for two, my third hour kind of had a on your own day today because I felt like we weren't ready to engage in learning. Regardless, these are what you were supposed to accomplish by the end. So you needed to be able to explain the meaning of A and B in an equation that represents exponential decay. So what does A represent? Initial amount. I like saying amount because like amount starts with A. Initial value, same thing. So whatever is going on in the situation, that's what we're starting with. All right. Also happens to be your y-intercept, by the way, when you graph it, but we use the letter A to say initial amount. What does B represent? So pay attention, especially my third hour. B represents what? Common factor. And what do I do with factors? I multiply them. So when you're figuring out what's my common factor, you're figuring out what's the number that I'm multiplying over and over again to get the next number. And it has to work that way. So sometimes we express B as this. We express it as the 1 plus or minus R. Because sometimes instead of telling us, that it's doubling or tripling or something like that, it says that it's decreasing by a fifth. Let's just do that. If it's decreasing by a fifth, guys, I need you to pay attention. I swear this is so helpful. Just understand it. If it's decreasing by a fifth, what is my common factor then? What would I have to multiply by each time to get the next number? No. What is 1 minus 1/5? 4/5. Well, maybe I just didn't agree. I've heard of some people talking. But, it depends what it's asking. If it's saying what is it decreasing by each time, you would say it's decreasing by 1/5 of its original value. If it said, what is my common factor? What's my growth factor? You'd say 4/5. If you're needing to set up the equation, you would set it up times 4/5. So I don't know, say we're starting with 100 times 4/5 each time. This would be my exponential function. All you need for exponential functions are an initial amount and a common factor. Sometimes it doesn't tell you common factor. Sometimes it tells you like a rate, something like that. And then that's when you use the 1 plus or minus. So your common factor is always after the 1 plus or minus. Does that make sense? Maybe? But that's what A and B is. You have to be able to explain the meaning of it. You have to be able to find the growth factor from a graph and write an equation to represent it. And to graph equations that represent quantities that change by a growth factor between 0 and 1. So 4/5, is that between 0 and 1? What's the equivalent decimal of 4/5? No. 4 divided by 5. Put in your calculator if you need to. Okay, so 0.8. Is that a number between 0 and 1? So when you are multiplying by something between 0 and 1, that's a decay function. You should expect the graph to be decreasing at a really fast rate from left to right. If you, and even if you are my third hour, if you looked at the notes online, kind of tried to understand it, we did have an exponential decay function. We did graph it. So if you could make a table of values and plug in different numbers for the exponent, and can make a graph for any function, even an exponential decay function. And then we looked at this problem and identified what our growth factor was, which is really not that different from the table. If you don't like looking at it graphed, make the table. This is the table that goes with this graph. Coordinates go in the order x, y on the table. If it's not clear what you're multiplying by each time, take one of the numbers, divide it by its previous number. So it's kind of like you're doing the opposite to figure out what times 100 gives me 90, 12.9. And then see if it's consistent throughout. 90 times 0.9, and I use the calculator, is 81. 81 times 0.9 is 72.9. So this is exponential. My common factor is 9/10 or 9. And my equation includes what I started with, my intercept, and my slope factor. If it asks you what it's losing each time, what would you say? Not 1/5. Different example now than what I showed you on my objectives. If it's keeping 0.9, it's losing how much? If it's okay, so remember this B is always, even if it doesn't look like it, 1 plus or minus R. It's decaying as we go, so we're going to look at the 1 minus R. If it equals 0.9, what does R have to be? 0.1. So it's losing 0.1 of its original value. It's losing 10% each time. So instead of doing whatever 10% of 90 is, and then subtracting it from 90, I'm just multiplying by what it's. Okay, so whether that makes sense or not, I mean, it's also people just clearly not paying attention. So I mean, you gotta know it by the time unit test comes around. The lessons are very repetitive. We ask almost the same questions every day. But I mean, I can only leave you there. I can't make you understand it. Anyway, that is that. I do think we met the learning targets, or at least if you watch the video, look at the notes, ask questions, you should be able to. The practice that you are doing for today is lesson 5. You're all here today, so I'm holding you accountable to it. Then you can go back and work on anything else you're missing. I have been updating your objective mastery scores. Like I just kind of spot check. I mean, I don't update grades every day, but usually a couple of times a week. So I do update those as you score higher on them. Some people are scoring a little too low and then just using time as free time. Don't do that. When I see that happening, I make sure never to put you to your friends because you need to score alone time, score high.